All right, friends, let's continue to our next video, expanding on what we learned previously on permutation and combination. So, to a quick refresher, permutations, ordering matters, combination, ordering doesn't matter. So, here is our permutation, and that didn't write anything. Here's our permutation, and that's the combination. Permutation involves ordering, combination, ordering doesn't matter. And then we also discussed what's the impact of repetitions on both of these choices. Repetitions obviously would give you more subsets. We looked at the ABC set here, and we were trying to collect subsets or rather unique subsets with repetition allowed of size 3 out of this entire set n equals to 3. And as we saw, we selected the first element, the second, and the third, and so on and so forth, branching out every time. So we can clearly see, at every point, we have the same number of choices as the number of elements in the set, which is n, right? So if I were to denote this in terms of time complexity, here I have n choices, here I have n choices, here I have n choices uh, for all my three slots. So basically, it would boil down to O of n to the power k time complexity. So you can clearly see here, right? So we have three choices for the first one, three choices for the second one, and three choices for the third slot, which is nothing but 3 to the power 3, ending up in 27. And this would be true for any case of n and k. If we were to look at that, if we added d and e here, and we can clearly see that would be 5 to the power 5. Right? So if we are obviously it depends on the size of k. Right. So let's proceed based on that knowledge. How about how do we code about this? So our typical recursive loop would have a for loop that would go and select the first element, because as you can see, if you look at the branch here, the left branch, it always selects the first element out of it, and then after it's done selecting the first one, it goes and selects the second one, and then goes and selects the third one. So, and let's say this is my for loop, right? And so if I'm supposed to select elements, so I would select uh, starting with 0th index, and I has to be less than the size of the set that I have, and that would be I would be incrementing I, right, every time. So that would be my typical selection process. And uh, what would be my exit criteria for the recursion? Let's say I have a function here, permutation, that is going to give me all sorts of permutation. So this is a recursive function, right? So what would be my exit criteria? The exit criteria would be, let's say I'm collecting these elements into sort of like a partial variable, which is let's say I have a partial variable here called string with the data type string. Let's say I have a partial variable, right? So I'm collecting as I'm going. I'm collecting so into the partial variables. I'll say uh, um, I'm going to call permutation here, and I'm going to say, okay, in this, it starts obviously with the empty string, but I say, okay, into my partial, I want to add the index that it is pointing to. Let me call that S, because we're assuming strings here. So S of I, right? And then uh, I need to know when this subset is going to be completed, right? Completed in the sense whether I have reached the size that I need. So what's the size that they have given us? They've given us the size k, right? So I need to pass k, and then I need to pass this bunch of other parameters, as in the original string s, and some sort of like a vector of strings. I'm talking C++ here, so I have a vector of string here in which I'll collect all my partial variables, right? So let's call that, well, just defining here result. So um, well, we don't need the data type here, obviously. So, but I just wanted to describe what it would look like. So the condition for this recursive iteration to end is when partial, right? So the partial is or the size of this partial string that I have, it's equal to k, right? So when it is equal to subset size, then I've collected it. So then I am going to store partial and return, store partial and return, right? And then return. So that would end the recursion here, right? So for this arm, and I would continue in the same way. So if we look at it from this example, right? If we look at it from this example, let me give myself a little more screen room here. Okay, so we started. Let's say we call this function from let's say any other function. Let's say we call this from maybe main or something, right? So we say that, okay, my string is uh, s equals abc, right? And then I'm passing you a partial, right? String partial, which will be an empty string, and then I need something to collect uh, the vector of strings. I need to collect uh, vector of string, right? So I need to collect the result here in this song. And I'm basically going to call perm here, okay? And to pass in this partial, and I'm going to pass in the string and the result and the size of each subset, right? So this is how it's being called. So let's look at it how this unfolds here from our code here, right? So let's look at it how this for loop unfolds. So first time when it comes in, it says that, oh, okay, I have an empty string, and I'm going to start with index 0, and I'm going to add to partial the first the element at index I, which is 0, right? So partial, if you look at this branch here, it's the recursion's first branch. So partial, let's call this partial here. So when it calls this partial, partial would have a in it, right? And then it comes back again and it says that, okay, you're going to start my loop again from 0, and then I'm going to add to partial the same element at index 0. So now partial will be a, right? And then I call this again and say that, okay, now I'm going to add one more to that, right, to partial. So at the same index, so partial will become and a, right? So now partial is 3a's. So when it becomes 3a's, and then it's called again, then it's going to check, is the partial size equal to the subset size that we need? Yeah, we need a k size subset. So it's going to return that, and well, store it in the result variable, and it's going to return. So we would, in our, let's say that we have result here, right, which is an array of strings. So we would already have stored a here, right, and we return back. When we return back, right, remember that this is a recursive column stack, right? So when this returns back, when this call returns back here, the partial is AA, right? So the partial was AA, and then and the index was 0, right? So I was at 0. So then I would be incremented, and it would say, okay, partial, give me what is at index 1, right? So at index 1, there's B. So now to partial, we are going to add B, right? So, and then that would be passed up. So the result would be A with B because partial was added B, and the size was 3. And then it returns back. Then again, I gets incremented, and this call returns back. I gets incremented, and I is 2 now. And at index 2, we have C. So we add to AA, we add C. So now we have AA and C, right? And if you look at it and if you work it out, you can clearly see that at every point we are adding the variable from 0 to whatever is the size of uh, and when we're trying to see whether we have reached our subset size, and if we have, then we are done with this particular branch. So at the end of this recursive iteration, we would have collected from this particular AA branch, we would have collected 3. So this branch is the AA branch would be done, right? And now we go to the A branch, right? So we go back to this branch where we have A, and that now the partial would be A, and we would select. It would have the index would have been 1. So now it was going to be the second index, right? So the partial would be added B. Uh, so the partial would be AB here, right? And the same thing repeats. If you see this, if you have partial AB, and then it calls permutation again with for I equals to 0, right? So then it's going to select A again. So we select AB, and then we get select A again, and then AB would again do 2 more iterations because the size of the subset is 3, and we already have 2 here. So we are just going to add 1 more to each of these. So that would be AB B and AB C, right? And then we'll be done with this. And if you follow in the similar vein, this thing unfolds, and you would be able to collect all of the uh, partials into this, and that would be about 27 of those. All right, so we look at the next one with the permutations with no repetitions allowed in the next video.